our session today here is from Data to Dialogue, Marriott's AI-powered analytics revolution. So I'm Dan McDonald, Vice President of Data Analytics Platform Engineering at Marriott. I've been in the business about 25 years, focused on technology. Started out as a developer, did some architecture work, made my way into the data space and have been working in the data space, data technology, analytics, and machine learning ever since.
And I'm Scott Reed. I had to put 12 plus here so I could be half of Dan. The privilege of being up here. I'm the solutions engineer that's dedicated to working with Marriott since the beginning of last year. Background's mainly in traditional ML. So anything in the whole machine learning lifecycle I've done and built, now kind of venturing into the Gen AI space.
Yeah, thanks for being here, Scott. Scott's been a great partner of ours from Snowflake as we've been on this journey. I'd like to start with an icebreaker. Typically start with a joke. Couldn't come up with a great joke, so when we can't figure out how to do something, I did what we all do. I turned to AI and asked AI to write a joke. First one wasn't that great, so I figured I would ask each AI agent to write a joke and we would have a little bit of fun. So my prompt was write a funny joke to open a presentation on Gen AI. I'm gonna read through these, then we're gonna come back and we're gonna do a quick vote and try to figure out what the funniest AI platform is. So we'll start with ChatGPT. Feel free to laugh, you don't have to, I won't be insulted, these aren't my jokes. So ChatGPT, why don't humans ever laugh at my jokes? Because I'm trained on LinkedIn posts, not stand-up comedy. Yeah.
Our second one's from Gemini. Before I start, I just want to reassure everyone that I wrote this opening joke myself. I could have asked a Gen AI to do it, but then we'd all be here for 10 minutes trying to figure out if the punchline was genuinely funny or just statistically probable.
That's a good one.
That's a good one.
That is a good one. Julia likes that one, I know. Yeah, very good. Okay, number 3 from Copilot. Gen AI is basically a magic trick. You give it a prompt and voila, it gives you something that sounds smart, even if it's consistently wrong.
Okay, last but not least, from DeepSeek. You know, working with Gen AI is a lot like raising a toddler. It's brilliant until it starts confidently telling you that a cat is a type of sandwich. And you can't blame it because you trained it.
That's actually a good one. Okay, so let's do a quick vote. Raise of hands. Number 1, funniest. Yeah. Number 2, funniest. Okay, all right. A lot of statisticians. Number 3, funniest. Okay, number 4. Very nice, very nice. Okay, so I was having trouble figuring out which was the funniest. So I took these 4. I went back to each AI and I asked them to tell me what they thought was the funniest. So it's pretty interesting. So ChatGPT and Gemini both picked number 4. Copilot and DeepSeek both picked number 2. Interestingly, no one picked their own joke, which I thought that was kind of funny. So then I decided to have a little bit of fun and I prompted ChatGPT and said, you wrote number 1, DeepSeek wrote number 4, so DeepSeek is funnier than you. And it gave me this very kind of whiny answer. So my conclusion is Gen AI and Gemini are funny while ChatGPT is a bit of a sore loser. All right, that's fun. Okay, so data to dialogue. So we're here to showcase conversational AI, a solution that we're working on using Cortex and semantic modeling. Trying to take over 500 KPIs that we use to run our business and make them accessible to decision makers in the organization through a natural language session. So a typical use case we're envisioning might be, I'm a general manager of the Beaver Creek Lodge. I want to know quickly what was my RevPar, that's revenue per available room, a key metric if you're a GM of a hotel. I may want to know quickly to compare it with last year. I might want to know what year to date looks like compared to last year. So rather than going through and looking for a particular dashboard and finding my answers there, which will still be very helpful and informative, I may just want to know very quickly at the beginning of my day as I think through the 100 things I need to do and all the decisions we need to make. Now, what's a little bit different about what we're trying to do here is make this decision grade, right? So we've all seen the demos where you ask, you type in a question and how many sales did I have last year? It gives you an answer, right? We assume the answer is right. Sometimes we see the sequel. The sequel looks kind of right, but we all know Gen AI is not always consistent, right? We've also asked the same question and gotten slightly different answers. So how do we get to something that we know is decision quality? We'll talk about that in a bit. So agenda, we're going to split this kind of down the middle. I'm going to talk about the Marriott journey, the journey that we're on, how we approached it, some of our learning, some of our next steps. Scott is then going to take us in under the covers within Cortex Analyst and really give us a deep dive of what's down in there and how does it all kind of come together. Marriott's an incredible company, started in 1927 as an A&W root beer stand in DC. Started serving hot meals in the winter, noticed that travelers were often stopping by to grab a quick sandwich to bring to the airport, connected the dots, started the first airline catering business, opened up our first hotel in 1957, opened up our first international hotel in 1975, actually just celebrated the 50th year anniversary of this hotel last week, went into the home and villas rental space, launched 3 luxury yachts, have luxury safari villas, and actually have a great partnership with MGM Resorts. We're able to earn and burn points as you travel to Las Vegas. This is all underpinned by Marriott Bonvoy loyalty. Any Marriott Bonvoy members in the crowd? Hopefully, awesome. All right, it's a great program. Hopefully you find a great value. If you're not a member, and you occasionally stay at a Marriott, you should join. It's quick, it's free, and if nothing else, you'll be able to skip the long line and go to the special line when you're checking in. So it's worth it just for that. We actually have a special guest here today, my esteemed leader, Julia Morrison, who is up on the big stage today representing Marriott, and I'd just like to give her a round of applause. Fantastic. So the opportunity, right? Text-to-SQL. Text-to-SQL has been around for a while, right? Started in the 60s, has progressed in capabilities, started to see some traction in the BI space. But what's really changed is the models, right? They've really kind of supercharged the ability to take a natural language question and generate structured code from it, right? And specifically in this case, SQL. So we feel that there's a great opportunity here in this massive leap of capabilities to further democratize the access to our data and really reduce the friction that it takes a leader who needs to make a quick decision to get to that KPI quickly, understand what's going on, make that decision and move on. So that's the opportunity that we see. The vision is that we're able to, again, create decision-grade results, right? An answer that a GM can make a decision on and know is correct, which we think is challenging with an LLM, right? Getting that deterministic results. And we'll talk about how we get there. Our vision is to enable 500 plus enterprise KPIs that we have through agents in different channels so that our leaders and general managers within our organization always have this data at their fingertips. We don't see it replacing Power BI and Cognos dashboards and reports and such, but we do see it as a great addition to that and potentially reducing the number of dashboards that we have within the organization. So this is our thought process we went through when we considered this. The first thing we thought about was, should we do something now or should we wait, right? There's tremendous innovation in this space. And And we knew that whatever we built today, it may only last 6 months, right? It may be like out of date because there's new capabilities. I didn't know that day would be today with the great announcements at the keynote, but it is such a fast-moving space. Should we just wait? And I think Sam Altman in the talk last night said, just do it, right? Like you got to jump in at some point. And so we decided let's jump in, and if nothing else, we'll learn. We may build some foundation capabilities that will live forward as additional innovation happens in the space, but let's just get started. So that was our mindset. The second thing we thought about was, should we look to a BI tool for these capabilities, right? They do have these capabilities. They do have pretty rich semantics. The challenge that we had is, we had a challenge and an opportunity. The challenge that we had is we have multiple BI tools, right? So bringing those all together into one experience is complicated. The advantage that we had is we just went through a very large reconciliation of our KPIs, right? Bringing them down to our 500 enterprise KPIs, and then built a number of data products underneath those that each data product is highly built to answer the questions around a certain set of KPIs. So we have very rich semantics in our data layer that we're able to leverage. So we said, you know, we're just going to build it. We're just going to build it outside of the BI tool. The third thing we thought about was, should we license a product, right? There are some great products out there that have been doing this, that are advancing with the LLM capabilities. We kind of felt like we didn't know what we don't know what we don't know yet. And so to evaluate products and make an informed decision, I don't know, we just felt like we don't know enough, right? So we thought if nothing else, getting through this exercise will inform us, we'll learn a lot. And if at the end of the day we think a product is the best way to go, we're gonna be very well equipped and informed to go evaluate products. And the last one is our decision grade results too ambitious at this point in the LLM maturity space? And we're gonna find out. We don't know, but that's our journey. So when we started, we kind of thought about architectures, and there's a lot of great architectures out there. Here's a couple of examples. One is an AWS reference architecture. Another is a Pinterest architecture that I found on Medium. Great architectures. But we also looked at these, like, there's a lot of moving pieces, right? There's a lot of technologies. There's vector stores, there's language chains, there's embeddings, and like I run a data team, right? I have the best data engineers in the world, right? And I really want those data engineers to be focused on data, right? Not necessarily hobbling together a tech stack in order to then provide data to provide a capability, right? It reminds me a lot of the Hadoop days, right? When Hadoop first came out, it was great, right? An incredible amount of different technologies. But we found ourselves probably spending 30% of our time just building the stacks and maintaining the stacks and upgrading the stacks and dealing with versions and all of the operational issues that come out of these components that maybe weren't ready for prime time, right? So we decided to go with the Cortex analyst reference architecture, right? And for two reasons, right? One is all our data's in Snowflake. It makes sense, right? The data's there, the capability's there, no moving data around. We love that. The second is that it's simple, right? And Sridhar, if you were at last night's keynote and you listened to Sridhar, right? He talked a lot about simplicity, right? That you want solutions to be simple, right? You want somebody else to worry about the complexity, right? You want to see it as a service that you can use to create capabilities and quickly deliver those capabilities to your organization. So those are our leading reasons for selecting the Cortex analyst. And as you can see here, there's really kind of two things you need to do to implement, right? One is you need to be able to call a REST API, right? Not all that complex. The second is you need to build your semantic model. And as data people, right, we know semantic models, right? If there's anything we know, it's semantic models. And so, being able to build a robust semantic model is really the secret sauce to making this work, right? It's really the one thing in this architecture that is going to get us to decision grade results. So you'll spend, if you head down this path and you use Cortex Analyst, you're going to spend the majority of your time getting your data ready, if your data is not already ready, and building a semantic layer that is going to inform Cortex Analyst on how to generate that SQL, how to consistently generate the SQL, and how to correctly generate the SQL. And that's what we're great at, right? And so that's where we decided to focus. Now, there's a lot that goes on in that very simple looking black box on the right. Scott's gonna take us through and educate us on how all of that works. The other kind of interesting piece in doing it this way is, like, you heard some great announcements today in innovation, right? You heard about semantic views, and you heard about the semantic SQL, right? So now we're able to go back and take advantage of that without ever touching what's in that black box, right? We know it's there, we know it works, we know it's tested, we know it's consistent, right? So we think it's an ultimate solution for a text-to-SQL application. So the semantic model primarily has three components. There's, I would call your data model, for lack of a better word, right? So you define your tables, your logical tables on top of your physical tables. You connect your dimensions, you identify and define your measures, you can define your time dimensions. It's typically a lot of the things that you would do when you're building out the semantic layer of a BI tool, right? This is where you take what is typically a very technical implementation of table names and column names, and you bring those up into something that's more natural language, right? And that's the key to making this work, right? When you're putting together your semantic model and you're putting in your metadata, right? Think like AI would think, right? When you're naming a table, right? Like be verbose, right? Like you want to provide as much information as you can, right? You almost want to provide more information than you think is needed. Think about your semantic model as your system prompt when you're operating an LLM, right? This is really where the magic happens. The next piece are the relationships or joins. The final piece, I'm sure there's more pieces that Scott will talk about, but in my mind, the final piece are the verified queries. So these are like, think about these as test cases where you ask a question, it generates a SQL, you get the result, you go check and you say, okay, that's the right result. You then tag that as a verified query, right? What Cortex does is it embeds that question, stores it in a vector store, puts the SQL along with it, right? And so now you've built out this vector store of questions, answers that you've deemed as correct, right? So now when somebody is interacting with it, the first thing Cortex does is it takes that question, right? It embeds it, it does a recency search against the vector store, and it gives you a score, right? And if that score, it's like a score of what, 0 to 1? And if that score is like in the 0.9 range, you have very high confidence that translation from text to SQL was correct, and very high confidence that that answer is decision grade. We could literally do a full presentation just talking about the semantic model, semantic layer. If you're going to do one thing, if you're new to Cortex Analyst and you're going to go back and you want to get started, start here, spend a lot of time understanding the ins and outs, and then start thinking about how you're going to create the metadata to drive this engine. So the approach that we took in the implementation. So as I said, we're actually in a very fortunate spot. We've recently come off of a very large 2-year initiative where we standardized and refactored all of the KPIs across our business. So we have a golden set of 500 KPIs that align with all of the different aspects of our business that are typically used to measure, inform, and make decisions on. We built rich data products that support some number of KPIs. And there's a lot of logic kind of built in, a lot of kind of rules baked into these data products and able to satisfy these KPIs, right? We then use these KPIs in all of our dashboards and such, but we had a really good starting point in this foundation. So we started there. We picked one and we created a semantic model using the semantic model generator. So Snowflake has a lot of capabilities to help you build semantic models. They're continuing to innovate on these capabilities. At the time we built this, the semantic model generator was there, so we kind of started there. But then we needed the metadata, right? We needed those rich business descriptions about our data, the tables, the columns, the data that's in there, the metrics that they support. So we turned to our enterprise data catalog. We use Atlan, and we pulled that metadata out of Atlan and put it into our data catalog. That was a manual effort, right? But there is actually work going on to help kind of automate and integrate that. And so if you do have a data catalog, like that's where you want to go as your first stop to get this rich metadata. We then thought a lot about testing, right? So when you build a dashboard, right, a big part of building the dashboard is testing. And we all have tried and true approaches to doing validations, right? We have test cases, we have automated tools, right? By the time we release a dashboard, we're pretty locked in that that dashboard is correct. How do you do that with a model, right? How do you do that with something you really don't have kind of control over? And by its nature, there's a lot of opportunity for it to, not give you a deterministic result. So we spent a lot of time thinking about it. I don't know that we've solved for it. So if anybody is ahead of us in this road and you've cracked that, would love to talk to you about it. We talked to a lot of people in the industry. The traditional answer we got back was, we got 2 answers. One was pair model. So send your question to 2 different models and then compare the results. And if the results match, then your model's correct. It's like, I don't know. You saw the jokes. They weren't that funny. I don't really have a lot of confidence that, 2 models is the answer. Another one was human in the loop. So show them the SQL. These are business people. They don't know SQL, right? Like that's absurd, right? Or show them how the question was interpreted. It's like, yeah, but that doesn't mean the SQL's right? So we tried to really lean into verified queries and are trying to build out that verified query repository to make that as robust as we can and kind of only displaying results when they come from a verified query, right? Because if they come from a verified query and that verified query is in that 95% decile, right? Then in confidence, then we're pretty confident that that's the right answer, right? But how do you automate that, right? How do you do that at scale, right? You can't have somebody sitting there typing in questions all day and checking the results, right? So we actually have some interesting ideas on how to really automate that and bring that to the scale we need to be able to create the semantic models in the verified database. We refined the semantic model, right? So once we kind of got it going and we got the verified queries, we'd do some testing and we'd see kind of maybe what worked, what didn't, and we'd go back and create more verified queries. So we're very much in this wash, rinse, repeat mode. And then finally, we built a quick chatbot using Streamlit to be able to people to be able to interface with it. It's not our end goal, but just something up and quickly so we can start to get some people using it and we can get some feedback. So scaling out. So how are we going to get to where we are today to a full-scale implementation? So we're going to spend time really investing in metadata within our data catalog. Again, with thinking coming at it with AI in mind, right? So as you're creating your table definitions and your business definitions and such, like think about it like an AI model and what information it's not really an AI, what information it needs. We're going to create a semantic model for each of our data products. So I think one thing you do when you create your semantic model, you're going to need a strategy, right? Do you create one Uber semantic model? Do you create multiple semantic models? For us, it just lines up very well. We have 30-odd data products. Each data product is kind of engineered to answer a certain set of questions. We're going to align a semantic model with each of those. Kind of two reasons, right? One, these semantic models right now are YAML, right? So it's kind of hard to manage a large YAML kind of file. The other is that what you'll find, and I'll talk about this in a little longer, is these things aren't fast, right? If you've gone and you've used ChatGPT, right? There's some think time for that to come back with an answer, right? And you'll see this here too. Like Cortex will, think about the question, right? I don't know, thinking, but all the stuff that Scott's gonna show us it does, and then it will come out with an answer. Now, that can be 25, 30 seconds, depending on the size of your semantic model. Now, if you're gonna put this in front of people as an alternative to reduce friction, it's gotta be fast, right? And 30 seconds may be great in the beginning when it's fun and shiny and look what I can do, right? But that's gonna wear off, right? And so reducing that think time is going to be very important. One of the ways to do that is to keep your semantic models kind of on the smaller side, right? So we're able to see like 15-second think time, which I think is good compared to what we've heard other people seeing, and that's just to generate the SQL, right? Now you have to go execute the SQL, right? But so you really want to reduce that initial think time. We're going to dial in that confidence score layer. Is it 0.9? Is it 0.95? Is it 1? Right? We really have to figure that out. There are some approaches to optimize latency that we're going to look at. Again, I think that's key. And that's all about trying to answer it without maybe hitting the LLM to generate the SQL, right? So are there strategies, or is Scott going to figure out strategies that make that run faster? So that's kind of part of where we're hoping it goes. As far as how you surface these, we're spending time on the model context protocol, which allows you to kind of integrate into some other front end. So we have a enterprise portal. It's our intelligence portal where folks go to consume reports and information today, right? We view this as a perfect place to kind of sit this interface, but there'll be other channels as well, right? We really want this to meet the person where they typically want to be to consume this type of information. So being able to quickly embed this in different applications is important to us. We didn't really spend a lot of time on the observability component, right? So I know it's TrueLens that Snowflake had purchased and now position that as their observability. Haven't really had an opportunity to spend a lot of time on that, but we certainly want to lean in there and see where that can help. And then there's this, so this is kind of like step one, right? Tell me what happened, right? What's my RevPar, what's my average daily rate, right? But then we want to kind of augment this with what you maybe see as some of the more advanced AI use cases on why is that happening, right? Give me some ideas on why my RevPar, this year is lower than same time last year. Now, what's kind of more fun about those is those don't have to be decision grade, right? They're ideas or things, they're thought starters, right? You're not necessarily going out and making a decision on that. So we think that's going to be more of a fun additive to this. And then eventually get to what should I do to address it, right? Which I think Sam Altman talked about a bit in the presentation last night. So lots to do, but a great start. So with that, I'm going to pass it off to Scott, and Scott's going to unveil what actually goes on under the covers.
It's a lot of pressure, Dan.
Yeah, I'm sorry. You got it.
Awesome. So I wanted to use the second half of this presentation to do a deep dive on Cortex Analyst from a technical perspective, but really highlight how it lends itself to the challenges that organizations face when creating talk to your data capabilities. So when you think about talk to your data capabilities, this is really a vendor agnostic aspirational architecture, right? You have a natural language input at the top. You have a series of agents and tools that will then kind of route that question and orchestrate as appropriate. Then you have a semantic and retrieval layer, as well as a data processing and data foundation layer. And the goal is to really obfuscate the user from the complexity under the hood, right? So a user comes in, like Dan said, these, they may not, know SQL, right? So they don't want to have a look under the covers, so to speak. They want to actually ask that question, get back a verified result that they can trust, right? And so, what we've seen here, Dan showed some reference to architecture earlier. What we're trying to do with Cortex, in case you hadn't heard, I know we're hearing lots of presentations, right? Cortex is our fully managed Gen AI service. Basically, we control all the infrastructure, set that up for you so you don't have to worry about that yourself, right? So Snowflake's whole goal is to make that as easy as possible for the users. When Dan and I started talking about this, the overarching goal I heard from Marriott was, how do we get to this future state? How can we deliver decision-grade quality to our users? But actually, how do we get started, and what should we consider, right? And there's actually a lot of things to consider, unfortunately, a lot of challenges. First being, should we start with structured data or unstructured data? Can it even do unstructured data? Which model do we use, right? So I know every week, maybe every day, there might be a new one today. There's a different model, right? And it's suited for one particular purpose or better than the last. So should we wait kind of for that next model, or should we act now? Do we need to build something separate for each team, right? Is what we build going to be scalable and applicable to multiple groups? And then what about business glossaries, data catalogs that may exist in the organization? Can we leverage those to make those text to SQL, those talk to your data capabilities even better? And so what we landed on was really this red box. So focusing on the structured data, Marriott's been building this data platform on Snowflake for years. There's so much rich content there, ready to be used, ready to be easily retrieved by analysts, right? So we wanted to focus on this box, which in Snowflake speak is Cortex Analyst. Even though we wanted to start with a talk to your data capability on structured data, it doesn't mean it's easy, right? In the Gen AI world, it may seem like the low-hanging fruit, but it's really not. Real-world data is extremely messy. It's really easy to create a demo that shows text-to-SQL capabilities, but when you actually bring it into your environment, when you're dealing with the nuance of your underlying data, it's extremely difficult. 10,000 tables, 100,000 columns, like these are not uncommon scenarios. Maybe you have different KPIs that are called different things by different teams, right? So how do you actually synchronize that? How would the text-to-SQL capability know those underlying details? And what about joins, right? I can remember I ran a team back in my old days that where we'd get these requests to fulfill reports, and some of those queries were just insane, right? So many joins. How could you expect like a text-to-SQL capability to handle that, right? One of those joins fails, you get a result that's not accurate, and there may be downstream implications, right? So Dan and I are very aligned on getting to decision grade, and Cortex Analyst is uniquely suited to get as close as possible to that decision grade criteria. Cortex as a whole, like I mentioned, this is our fully managed service. When you think about Cortex Analyst specifically, it has its own kind of managed service underneath, right? So I'm going to show that architecture that Dan had up earlier and kind of walk through what's in that black box, so to speak. But that is a fully managed service in and of itself, powered by multiple LLMs, an agentic workflow that basically that workflow combined with the accompanying pieces of the semantic model, the verified query repository, the custom instructions, right, the metrics you define, ultimately gets you to that industry-leading, 90+% there in terms of accuracy. To me, there are two things that really make Cortex analysts work like magic. The first is everything Dan talked about, right? The semantic model, verified queries, custom instructions, some of the things that will be announced this week, like taking a dashboard and automatically inferring and creating the semantic model. But then the second piece is actually what Snowflake manages on behalf of organizations that they don't need to worry about. So going back to what Dan showed earlier, steps 1 and 4 here are really on the organization, the users to manage, right? So step 1, that's the request, right? So what do I need to do to get started there? I need to create my semantic model. I need to choose a deployment method. Maybe it's a Streamlit app, maybe it's a custom app, basically where I'm going to call that REST API from. So Dan here is thinking, hey, is the semantic model good enough, right? Have we provided enough guardrails to get to decision grade? Do we have the right data in Snowflake to be able to pull this off to begin with, right? And then step 4, right, that's the return SQL query and interpretation of that original question that came from the user. So how should we process and show that within the application? Is this the expected kind of query or result, right, based on our testing? Does it answer questions about our KPIs that we want it to? And ultimately, does it enable self-serve analytics at scale, right? And start to reduce our reliance on dashboards, like on canned dashboards. That's kind of a secondary goal. What organizations and users don't have to worry about is steps 2 and 3 here that you see, right? Everything that happens inside. And so what happens within those steps 2 and 3 on that previous slide? You have a series of agents, right? You have, starting with the top, when that question comes in, you have a classification agent that acts as the gatekeeper, right? So it's going to check if what it received is ambiguous or unambiguous. If it's ambiguous, it might send it back to the user with actual answerable queries that it knows, right? Suggesting, hey, did you mean this? If it's not ambiguous, it's going to go down to the next agent, which is the feature extraction. Within the feature extraction agent, it's looking for clues as to help the downstream SQL generation agents. So it's going to say, is the user looking for a specific time period? Is the user trying to rank? Or is the user trying to compare, right? It's going to use those parsed inputs from that question to kind of give hints downstream to the SQL generation agents. Next, you have the content enrichment agent. So Dan and team spent a lot of time on that verified query repository. So this is where that would come into play. It would go and grab those verified queries as needed to kind of automatically give you that deterministic result if it knows it based on that vectorized path. Then you have a series of SQL generation agents. So each of these is going to answer that question with a different LLM. And so then it will go through a series of corrections, right? The correction agents for each SQL generation agent will look for syntax and semantic errors and kind of issue a correction loop if needed. And then you have a synthesize agent, which will take all of those and then ultimately provide both the interpretation of that user question along with the SQL query itself. And so, Gen AI is moving really fast. In my opinion, organizations should be prioritizing delivering more immediate value, right? All the things that we've heard from Sam and Sridhar yesterday, we should be iterating fast, right? Not necessarily waiting for the next model, but testing and having an opinion on like what works in our environment with our data. Start small, prove it out to add value, and then move on to the next, right? So couldn't be more excited to work more with Dan and team on a number of things that he mentioned, off the top of my mind, multiple semantic models. So going this week into GA, I believe, is semantic model routing. So if you have, let's say, multiple teams they're going to want to ask questions about different types of data. If you have different semantic models, Cortex will be able to route those to the appropriate semantic model. Things like leveraging model context protocol for multiple tool use and like actual agentic flows. So not unlike what you saw in Snowflake intelligence, right? The ability to work between multiple sources of data and do different things. And then also adding unstructured data, right? It's something we haven't quite talked yet about, but I think there's tremendous upside there too at Marriott.